So this is chapter 4, number 32. Number 32, I'm going to take a second and take a look at something. So I'm going to derive this in the abstract, and then we can use it on future things. So if you think about x equals v naught cosine theta t, and then y equals y naught plus v naught sine theta t minus 1/2 gt squared. This particular problem, it tells us we hit a home run, it goes 130 meters, we get to a height of 21, we are launched the bat or the ball from 1 meters, and that we know the angle. And in this, we don't know time. Again, we know how far the ball went horizontally, the vertical rise of the ball, and the angle it was hit, but we don't know time and we don't know the original velocity. But if you know this information, it's enough to figure out everything else. If you think about it in the abstract, if I solve this for time, time is going to equal x over v naught cosine theta. And then I'm going to plug that in over here, and I'm going to get some different relationship. Well, it's just not going to have time in it anymore. So that's x over v naught cosine theta minus 1/2 g, and then t, but t is x over v naught cosine theta squared. If you simplify this equation, you get y equals y naught, v naught and the v naughts cancel, sine over cosine is just tangent, so that's just plus x tangent theta, and then this is just gx squared over 2 v naught squared cosine theta squared. If you look at this, we have all of these values. We needed to go up to a 21 height, starting at 1, going 100 meters, launched at 35 degrees, minus 9.8 times 130 squared times 2 times what we don't know, times cosine of 35 squared. The only variable in this relationship now is how fast we hit the ball. So graph this is y1, this whole thing is y2, and find the intersection, and you figure out that we must have hit the ball originally at 41.7 meters per second. But once you know that, well, then you can come back in over here and just say, well, it went horizontally, this relationship, that if it went 130, being hit at 41.7 at an angle of 35, how long must it take to get there? And you can get a time of 3.81 seconds. Well, once you figure that out, then when it crosses the home run fence, you can figure out its components. So Vx is going to stay the same. Vx is not affected by gravity, and so it's just v naught cosine theta, and you should get 34.16 meters per second for that. And then vertically, it gets hit originally at 41.7 sine of 35 degrees, and then it's pulled down 9.8 meters per second squared every second for 3.81 seconds, and that ends up being negative 13.41 meters per second. So when it crosses the home run fence, it's moving that far horizontally, and it is coming down, and that is really the questions, because if you look at the questions, it wants to know: find the initial speed of the ball, did it. Find the time it takes the ball to reach the wall, did it. And then the velocity components when it reaches that.